Hello and welcome to another fabulous day learning about inverses and calculus. Inverse functions in particular. So the first question is what is an inverse function? Well, we already know that f of x, right, we'll take inputs, take them to outputs. Right, so if 1 goes in, 3 comes out. Boom. F of 1 equals 3. And an inverse, well, an inverse function takes outputs and brings them back to inputs. So if this is f of x, f prime of, or not f prime, goodness gracious, f inverse of x, which is denoted with that little -1, we'll take the outputs and put them back to inputs. Consequently, f inverse of 3 equals 1. Functions do, inverse functions undo. Pretty straightforward concept. Consequently, look at this table here, right? Once again, f of 1 is 3, f of 2 is 5. I can even say, hey, without this table, I know that f inverse of 8 is what? Let me give you a second to pause the video or think about that. F inverse of 8 would just be 7, right? Because right here, we're just swapping our inputs and outputs. Now, why does this matter? Every year on the AP Calc test, there's 1 to 3 questions on inverse functions in calculus. Now, this we haven't done any calculus, but let's get around to a little bit more of what inverse functions do. Ultimately, functions do, inverse functions undo. But let's take a little closer look at this, right? And let's just write something kind of fun. Let's consider f inverse of f, and again from this table, of 1. Well, f of 1 is 3. We already knew that. F inverse of 3 is 1. And notice these numbers are the same. Very circular, cutesy logic, right? And I could have done this with 7 and 8, gone back here. And also keep in mind this works both ways. So I could have written f of f inverse of, I don't know, what's your favorite number? Mine is 2. Well, what's that going to be? Well, these just sort of cancel out, so that's 2. And we can extend this to make that f of f inverse of x equals x, right? As long as these two things are the same, we're kind of in the right. Now, I see composite functions, and my brain instantly goes towards what? Well, that looks like a composite function. I'm going to use the chain rule and just see what I find. Well, if I use the chain rule, well, let's apply d dx to each side, as one does. The right-hand side looks a little easier. That's just 1. But my left-hand side, I have an outer and inner function. That's f prime of f inverse of x times f inverse prime of x. That is the dumbest looking thing I think I've ever seen. F inverse prime. Wow. Take a gander. But why does that, let's just get that by itself. That means that the derivative of the inverse, and I'm just notate it like that, is equal to 1 divided by f prime of f inverse of x. Nothing too crazy. The key is just remember, if you don't even need to remember this. The only thing that's really worth remembering about inverses, the only thing that I have memorized, and as you know, if you're watching this video, you know that I am a genius. The only thing that's worth memorizing is this, right? F of f inverse of x equals x. If you have that, you can do your derivatives, blah, blah, blah. Now, what does an actual AP question look like, and how can I use this? Here we have little table, and notice all we have is f and f prime of x, and we have the question, find f prime inverse of 6. Well, shucks. I don't remember my inverse formula, but I do remember that f of f inverse of x equals x, always. So meow, f prime, let's apply d dx to each side, of f inverse of x times f prime inverse of x, f inverse prime, f prime inverse. I'm probably doing, someone will surely tell me that I'm wrong on that. Equals 1. What do I want? I want f prime inverse of 6. I'm just going to divide this over just to carry this through. Equals 1 over f prime of f inverse of x. And I want f prime inverse of 6. Well, that's just 1 over f prime f inverse of 6. All right, well, what's f inverse of 6? So now 6 is the, I'm looking right here, right? Because 6 is now the input to f inverse. So f inverse of 6 will be 2. So really, f prime inverse of 6 is equal to 1 over f prime of 2. And, oh, snap diggity, f prime of 2 is 1/3. So this is really 1 over 1/3, which is 3. Oh. So again, I do not have this memorized, but I know how to read these tables. I think the biggest leap here is remembering what f inverse really is, right? F inverse just takes, hey, now you're starting with outputs, now you're getting inputs, all right? It's not more complicated than that. Let's look at another example that I unearthed. This is more traditionally what one of these AP questions will look like. G of x is equal to f inverse of x, find g prime of 6. So really, I'm just gonna mark right here. That's really f inverse prime of 6. So I'm gonna do my same thing that I did last time, because even from the last page, I do not remember. But I remember that f of f inverse of x equals x, right? This does nothing, right? My input is my output. I remember that I remember the chain rule, because I have the best calculus teacher in the world. F inverse prime of x equals 1. God, this just looks awful, doesn't it? But take a second, pause the video. And remember, that's just f inverse prime. I'm pretty sure I've written it both ways, f prime inverse or f inverse prime. I suck. I'm sorry. I genuinely don't know which one is correct. The literature is terribly lacking. And I'm just going to divide that over, just because I like that to be all set. F inverse prime of x equals 1 over f prime of f inverse of x. And I want to plug in 6, so f inverse prime of 6 equals, now I'm ready to get moving and grooving. I'm just plugging in 6. F prime of f inverse of 6 equals, all right, so I need f inverse of 6. That's the firstest thing that I need. Firstest, not a word, is a word today. You're welcome. So where is 6 in output? Take that back to an input. So I am looking for 3. So this whole thing becomes 1 over f inverse of 3. 1 over f prime of 3. All right, well, what's f prime of 3? That's just 2. 1/2. A lot of these will use tabular functions, and I swear to gosh, I do not have this formula memorized. The only thing that I have memorized is this. If you have this, you're making money. All right? Don't work that hard. Don't memorize this. This is what you'll get if you Google derivative of an inverse function. All you really need to know is that inverse functions undo, right? The outputs are the inputs are the outputs, blah, 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 blah. All right, hope this was helpful. Have a magnificent day. Bye-bye.